let's find a few minutes following some limits by producing graphs. I want to take a look at a graph of these functions, and based on the graph, I want to try to figure out what the limit is. Okay, so here's a piecewise function, and I want to know what the limit as x approaches 3. This might be kind of small on your screen. This actually says as x approaches 3 of g of x, where g of x equals 2 for x not equal 3 and 0 for x equals 3. Okay, so let's draw a graph of this. Here's my xy axes. Now it says that x equals 2 for x not equal to 3. So here's 1, 2. So that's a horizontal line everywhere at 2, except when x equals 3. Let's see, here's 1, 2, 3. When x equals 3, there's a hole right there, and we said that it actually is equal to 0. So I'm going to draw it like that. So this is the line y equals 2. Here's x, here's y. Okay, so that's what this piecewise function looks like. So what's the limit as x approaches 3? Well, as x gets infinitely close to 3, let's start from the right. What's happening on the graph? Well, on the graph, I'm up here at y equals 2. As x approaches 3 from the left, as x gets infinitely close to 3 from the left, what's happening to the graph? Well, the graph is up here at y equals 2. So what does that tell me? It tells me this limit is equal to 2. Because as I approach from the right and I approach from the left, I'm approaching the same value on the y-axis too. Even though at x equals 3, f of x is not equal to 2. It's equal to 0. There's this jump here. But the limit, as I get infinitely close, as x gets infinitely close to 3, pick a spot. I don't care how close you can make it. Make it as close as you possibly can right there. What's the value of g of x? It's right here, which is 2. Pick a spot as close as you possibly can get on the right-hand side to 3. 3.0000000000001. Where am I on the graph? What's the value of g of x? It's up here at 2. So this limit as x approaches 3 is actually 2. Now let's take a look at another one here. This is, in case it's too small to read there, as x approaches 1. What's the limit as x approaches 1 of h of x? And here's my piecewise function. Well, let's go ahead and draw this again. Let's see. I have 1, 2, 3 on the y-axis. And things change at 1, so x equals 1. That's where things are going to change. So for x greater than or equal to 1, the value of h of x is 3. So it's right here. Greater than or equal, I'm going to include 1. So it's going to look like this. For x strictly less than 1, the value of h of x is going to be 2. So that's an open hole, and that's at 2. See, this is 1, 2, and 3. So that's what my function looks like. All right, what's the limit as x approaches 1? Well, let's see here. As x gets infinitely close to 1 on the right-hand side, what's happening to the graph? Well, I'm at 3. But what happens as I get infinitely close from the left? As x gets infinitely close to 1 from the left, what's happening on the graph? I'm at 2. So the right hand approaches one value, which is 3. The left hand limit approaches another value, which is 2. So this limit does not exist. For a limit to exist, it's got to go to the same value. As I approach 1, I have to approach the same value, like I did here. As x approaches 3 up here from both sides, the value I approach on the y-axis is 2. That limit exists. Here, because I approach 3 from one direction, 2 from another direction, we say the limit does not exist, because this notation, when I say x approaches 1, the implication there is that I approach from both the left and from the right. Okay, now let's take a look at this one. The limit as x approaches 0 of f of x, where f of x equals the absolute value of x over x. Well, what does this graph look like? All right, let's start off with x negative. If x is negative, absolute value of x is going to be the positive of that. So let's just say this is negative 2. This would be 2 over negative 2, which is negative 1. Let's say this is negative 5, or x is negative 5. Well, this is going to be 5 over negative 5, which is negative 1. So for everything less than 0, this is going to have a value of negative 1. When x gets bigger than 0, I have, well, the absolute value doesn't make any sense anymore, or at least it's not needed, because it's already positive. Everything bigger than 0 is positive already. So this is going to be 1. So this is at 1. But what happens when x equals 0? Well, when x equals 0, I get 0 over 0. Well, that doesn't exist. So this has a hole, and this has a hole. So now, let's go back to the idea of what is the limit. Well, as x approaches 0 from the right, as x is really, really close to 0, where am I in the graph? Well, I'm at 1. As x approaches 0 from the left, I get really, really close to 0, I'm at negative 1. There's two different values, therefore this limit does not exist. Now, what we use here in this little graphical display and discussion is actually the idea of one-sided limits. We took the limit from one side, then the limit from the other side, and made a comparison. So, the next thing we need to do is take a closer look at the idea of one-sided limits.